Hey there, this is Pete Lavasser with the Rust content team here at RustConf 2025 in Seattle. So I'm sitting down today with Christian, and he'll be sharing a bit with us today about his experiences with Rust and GPUs and these sorts of things. So yeah, without further ado, could you maybe tell me a little bit about yourself? Kind of what was your path? What was your journey to get here to sitting in this chair?
Yeah. Thanks for having me. I am a Rust community member, so I am a maintainer of rust-cuda and Rust GPU. So rust-cuda lets you write Rust code, and it's a custom compiler backend that then turns your Rust code into the basically assembly that runs on the GPU. And I've done that just as an enthusiast, and it's been great. I started my career working at Apple, worked on Mac OS X way back in the day before the iPhone. Then I went to Mozilla, so I'm a big open source fanatic. And I worked on Firefox there. After that, I went to Facebook, where I worked on all sorts of distributed systems and mobile and all sorts of stuff, and got to see some cool scale. And then after that, I went to Robinhood and got to work on the financial industry and saw their sort of challenges. And I picked up Rust because I had been managing so long and using other languages. I wanted to learn something new, and I looked around, I'm like, wow, all the smart people I know are learning Rust. And like, oh, you could maybe use the same language for like firmware and maybe even some of this web stuff with WASM. And that seems like a worthwhile thing to invest in. And I've used a ton of languages, and I sort of just fell in love with Rust. And so much so that we're starting a new company around Rust on the GPU, because again, my personal opinion is that GPUs are sort of the future of computing, and I want Rust to be there because I like programming Rust, and I think it has some very unique features that make it amenable to GPUs.
Nice, yeah. You've had quite the journey, the path. That's really cool. So you mentioned about seeing sort of this shift that seems to be occurring, where it's like, okay, more compute is going to be moving to GPUs instead of CPUs. And so I'd like to understand maybe a little bit more of the background there. Like, what are the drivers you think for this occurring, and what are the like downstream effects of this happening, of there being more compute moved to GPUs?
Yeah, I mean, I think AI, number one, is the killer app. Again, I liken it to sort of like the PC shift was, when PCs came out, the killer app was spreadsheets. And you got a PC because you wanted the spreadsheet because it unlocked new stuff. And that's sort of what's happening with GPU. The killer app is AI, and people are like, we need AI, therefore we need GPUs. And it's sort of driving everything, not only in the data center, but for local private AI is driving your phones to get better GPUs, or at least have their CPUs kind of be a hybrid. And so I don't know if GPUs will overtake. I think they've already taken CPUs, but I don't know if they will be that shaped. But I think if you look at CPUs themselves are starting to add, tensor cores and stuff like that. So you're sort of seeing, at the very least, they're going to converge, if not GPU just completely take over. And that's just kind of where all the money is right now, and it's on every layer of the stack. And I think it's you kind of need to skate where the puck is going rather than where it is.
Yeah, you'd mentioned this and kind of used this terminology I found really cool as descriptive: GPU-shaped problems versus CPU-shaped problems. Could you maybe help me understand a little bit more about, so AI is there, so that's a GPU-shaped problem. What are the other kinds of problems that either you have experience with personally or just kind of have seen that might be GPU-shaped?
Yeah, I think computer vision is another one. In my view, the next kind of wave of craziness coming is the robots and things like that, and that's really enabled by GPUs, because computer vision is, again, it's sort of like massively parallel and lots of matrix multiplications, and so that's the sweet spot for GPUs. But again, I think over time, GPUs are going to get a little bit more general, just because there's demand for that, to use them for different use cases, and they will always need to be parallel-shaped problems, but I think we're not sure what use cases on the CPU will also be compelling in the GPU. Like, we know a couple of them. Like, again, we know AI and we know robotics and we know stuff like that, but who knows, once we have millions and millions of GPUs and data centers and phones, of like what other use cases will be super compelling.
So if you build it, they will come, maybe. Might happen. So if you build it, then folks may start thinking about, I'm actually running into a bottleneck here. Maybe we should try this workload on the GPU.
Absolutely, and I think like web browsers, they use the GPU obviously for a web GPU, but there's parallel shaped things that people didn't think could be parallelized. I can't say that word. And then somebody found a better algorithm for, let's say, parsing HTML, and now they're doing it in SIMD, not in GPU, but that's sort of the first place to stop before you go to the GPU. And now all the browsers do that. And so we don't really know, once we have a hammer, we're not really looking for problems, but now we have big hammers, and I think we're going to start finding problems to hit with it.
I got you. Okay, that makes sense. And so you touched on this a little bit earlier of kind of bringing like peanut butter and chocolate together here. So Rust plus GPUs, and you talked about some of the open source work you've been doing. How do you see Rust playing a role in the GPU space? How does it factor in?
I think number one, the ergonomics are just so good. The ergonomics of GPU programming today are not great. And when you're working on it, you're like, oh man, I really miss things like cargo and kind of all the nice things that go along with it. And our expectations are just much higher now than it used to be in the past. And I think Rust itself as a language really has features that lends itself. So GPUs are obviously super parallel and concurrent, and one of Rust's thing is fearless concurrency. There's a lot of who owns what memory on the GPU, not only on the GPU itself, but on the GPU and the host. And then of course Rust supporting no standard sort of means that you can turn things off, because obviously the GPUs do not have an OS, at least not currently. Maybe that comes in the future, and it's nice to not kind of invent a whole new ecosystem. There's existing Rust crates that you can actually take from crates.io and use, and that's something that hasn't existed on GPUs before, and that's because most of the languages don't have these sort of combination of features. There's GPU-specific languages that don't have an ecosystem. There's sort of banging existing languages onto it, but they don't have things like the borrow checker. And kind of Rust has this sweet spot of, this actually maps pretty well to what's needed on the GPU.
I got you. So in terms of, I'm curious, like, is it sort of yourself in the basement, like hacking away on these things? Or are there contributors that are kind of jumping in? Like, how lively is the ecosystem around, say, these open source projects?
Yeah, I think it's pretty nascent right now. Rust GPU, which is compiling Rust to Vulkan. So you write your kernels or your shaders in Vulkan. That has maybe 3 or 4 maintainers, and then people come and go. rust-cuda has 3 maintainers, and again, people come and go. There is a PTEX, which is sort of the CUDA assembly backend in Rust-C. They target a little bit lower level than rust-cuda does, and that's 1 or 2 folks. And so it's a small team of us. We're like, most of us don't get paid to work on this sort of stuff. And that's, again, partially why we're starting a company around this is to kind of get the resources and put resources towards this and speed it up and get folks thinking about this full time.
I got it. So the idea would be that some of these folks that are some of the kind of like core maintainers of these key crates and maybe that backend for generating from Rust down into PTEX, I think you said it was called, would kind of hop into this new company, and that way to really ensure that there's enough support, people can make a living doing these sorts of things that we'd like to see grow with Rust plus GPU.
Totally. So yeah, some of those maintainers and contributors are coming on, and then to make it more sustainable. And then, I think we'll also be looking for, there's a compiler backend that sort of makes it possible to write Rust software to run on the GPU, but then sort of what's next? What software do we write to run on the GPU now that we have these tools? And so, that's where we're really wanting to target of these new use cases, these new applications that are GPU specific. And the compiler is sort of a means to an end to get Rust there, right? So we definitely need compiler people. We definitely need Rust GPU, rust-cuda shaped people, but we'll be looking for folks that want to write like applications and help us sort of flesh out the sort of higher level user language level kind of APIs and make it very ergonomic and feel Rust native and not so much GPU native. We want it to be easy to kind of go, I'm a Rust CPU programmer, and now I want to add some GPU stuff in there, and we don't want people to like relearn a bunch of stuff. We want a lot of progressive disclosure.
Right, yeah. Ideally, I suppose, sprinkle in some things here and there, like maybe change your backend that you're targeting, your target that you have for your compiler, and it, just works, right?
Yeah.
Like that's kind of the...
Yeah, it's like on CPU where you have, usually your code you write doesn't care about if you're running on ARM or i386 or whatever. But if you do need to, Rust gives you the tools to sort of target that. And I think that's our vision for the GPU is like, it should feel like writing CPU code. And then when you need to sort of dig in and do something architecture specific or like GPU specific, you have the tools to do it. But you don't have to kind of eject out of the Rust ecosystem. And it's a simple configure or a different dependency or something like that.
Got it. Yeah, and it's really heartening to hear that it seems like y'all want to like work upstream. Y'all want to work in the open and work with the community. So if folks wanted to get more involved and contribute to these things, I'm sure we'll figure out how to put links for things. But is there a best place to get started? Like, how would they get involved?
Yeah, I would say if you're interested more in CUDA, it's the rust-cuda project. If you're interested more, and it's just on GitHub showing up. We don't currently have a chat. That's a conscious choice. So we're using GitHub discussions and GitHub issues, just because there's a lot of noise in the space. And so yeah, showing up, trying to write stuff using those projects and going, I hit a rough edge either in documentation or in something missing, and actually digging in and trying to fix those, I think is super valuable. And like you said, we've been pretty much downstream a bit, and we're going to be pushing a lot more upstream and kind of working with the language and the compiler team. So you'll see a lot more of us, and there'll be a lot more opportunities to sort of inject. And this is also, I think, this is, again, never really been done before, especially not on the Rust side. So I think there's a lot of opportunities for folks in school to do research of what does it look like to bring the borrow checker to GPUs, right? Like how does that look like? Like what primitives of Rust map best to the GPU and kind of what are you giving up or gaining safety-wise? Like, and so I think there's a lot of interesting papers and theses here. And so folks are interested in the space. I think it's a good time to jump in.
Got it. Makes sense. And so pivoting, you had mentioned a bit about this journey you'd taken along the way. You've seen different things. You've written code. You've led smaller teams. You've led larger organizations. Maybe scaled some of them up. And then you sort of said, I want to do more code. Like, let's pick up Rust. Let's do some stuff with Rust. I'm curious to hear from you. Are there maybe challenges or things you faced in the past with running teams, scaling teams that you feel Rust could have some unique advantages in this space to help with that?
Definitely. And I think, Rust really shines at big code bases. The type system, the tooling, obviously compile times we're working on them, but and I think that's really when it shines, and that's non-obvious when you're working with like one or two people or on your own things. It's like when you have hundreds of people working on the same code base, the features Rust have like really makes the code base maintainable. I think in the past we used some other languages that had GC, and you almost always end up tuning the GC, and or you use something like Python, which is a great language, and at some point you go, I need to kind of dig underneath, and I need to go to the C code or write a C extension to use it from Python. And one of the nice things about Rust is like you kind of don't have that layers where now suddenly you're like, I'm a really good Python programmer, and now I have to like do a bunch of C, and I'm fish out of water. Where Rust, you can sort of start where you need to for your business, and you can go like as far down as you need to be because it's a system language. And I've seen that it sort of works until it doesn't, and then you're sort of scrambling. And it's nice with Rust that it's more of a kind of linear experience and ramp.
Got it. Yeah. This is some feedback that I've been hearing in just kind of like various spaces is that, so for example, like if you had started your career like a hypothetical person who had started their career with, say, like the C programming language, maybe like back in the day, like you could have, in theory, stayed with the C programming language up till today, right? Like if you had picked the right industries, the right fields, and that Rust may be forming into a language that could be chosen for many different domains throughout an entire career. And so I find that a really interesting and compelling thing about Rust is that it does scale in the way you mentioned. So yeah, thank you very much for sharing that kind of feedback about it. And so kind of pivoting back to Rust plus GPU, the thing that I'm curious about here is the lay of the land today may not be the lay of the land in say like 2 to 3 years on Rust plus GPU. We've talked about like maybe we sprinkle a couple things here and there, pick a different target, pick a different backend for the compiler. What would be maybe like the lay of the land today if somebody is like picking things up? What would they kind of stub their toe against?
Yeah.
Could you maybe flesh out a little bit of what they might run up against in that case?
The first is almost no documentation. We've been sort of making it work first and kind of not been doing the documenting side of it. I think the second is you have to sort of really know Rust, and you also have to know GPUs, right? So it's not really abstracting. We sort of are showed where it's sort of the lowest layer of, hey, you can actually control this GPU stuff, but you need to know the details of kind of how it works. And it's completely not integrated with the borrow checker right now. With the way GPUs work is you sort of take the same code and it runs, thousands of times. And so within that piece of code, the borrow checker obviously works, but then in the context of all those, thousands of copies running, the borrow checker isn't aware of it. And so again, we kind of did the bare minimum to get it work. So you'll go like, wait a minute, I could write to this buffer, two things can write to this buffer is because the view is an unsafe view right now. It's like, hey, let you do everything you can do on the GPU. And that's sort of that'll be a focus going forward of like putting in the guardrails you expect from Rust. We had to is this even possible first? And it turns out it is. And now we're like, okay, let's use all the goodies that Rust gives us. So it's very much a Wild West right now. We're not breaking too much code, so it's not like you have to rewrite everything, but it's, and then GPUs themselves are just quite honestly painful. So even printing, if you do printf debugging, that's hard on the GPU. It's easier on CUDA.
That's what I do,
it's wild. You have to enable a Vulkan extension to get printing back, and that's again because printing isn't a simple printing. It has to go into buffer in the GPU. The CPU side has to read it and then make sense of it. So, and you don't want to do that all the time. That could potentially be overhead. So you kind of have to opt into it. So there's these things that on the GPU are just debugging them, figuring out performance-wise. There are tools out there, but it's they're really young and raw and not as robust as CPU-based stuff. So it is a rough ecosystem, but it's not specific to Rust on the GPU. The GPU itself is just
it's more like the GPU ecosystem for these kinds of things where hey, I want to debug and I'm a caveman and I want printf debugging. Okay, you may have a little bit of a hard time right now, and the story is still kind of forming.
It's still really early, and GPUs have always existed for video games and stuff like that. But even video games were written sort of CPU first, and then let's send some drawing calls over to the GPU.
Okay, right.
And only now are they so the code that ran on the GPU and even in AI is very they're functions basically. It's run this function on the GPU. And only now are we starting to video games companies, for example, have been doing a multi-year process to move more stuff from the CPU to GPU first, and then AI is roughly doing that too. They're hey, what if we call 2 functions on the GPU? That's great. That's almost twice as fast.
That's wild.
Right?
Let's do it.
It's crazy, right? But again, because writing complex software in the current GPU stuff is very hard, and so of course you don't need all these crazy debugging systems or things like that because you're well, the software running there is not super complex. And I think we're just at this point where people are we want to write more complex GPU software. The tools aren't there. The languages aren't there. So there's a lot of kind of upwelling right now, but it's still very, very early days. The GPU is just much younger than CPU.
Got it. Yeah. I guess, again, I'm not in this space, so I don't have a lot of insight here, but my feeling has been that it's been a lot of relying on the raw horsepower and just things improving year over year. And there's maybe this concept of maybe we should also think about more sophisticated ways and more clever ways to make use of these GPU resources. And that induces a bit of a learning curve. How do we go about doing this?
Definitely.
Got it. So the other bit that you mentioned is currently you need to know Rust, you need to know GPUs. It's a little bit rougher on the edges currently. Is the intention, we've seen this pattern, I guess, in the Rust community of, okay, you have a sys crate, a dash sys crate that's a bit more if you know what you're doing and you truly need the raw horsepower, use this. But we offer some non-sys crate above that you can use if you want some of Rust's kind of guarantees. Is that kind of the direction you see yourselves kind of like heading towards?
I think so. I mean, I think just like CPU Rust, we have sort of a bundle of unsafe in the standard library to kind of get what needs to be done.
Right.
And then we have abstractions on top. And I think we want to follow the same model on the GPU. I think that's partially why GPU programming right now is kind of painful, is the majority of stuff is, in other ecosystems for other languages are targeted at that sort of unsafe, just raw intrinsics almost layer.
Gotcha.
And only now, NVIDIA just recently announced their Python, you can take simple Python functions, I think, and run them on the GPU. And it will sort of take their Python and convert it to GPU specific stuff. Obviously, you don't get the control you would in other languages, but that's sort of the first one I've seen where you're looking at higher level abstractions, and we want to do that in Rust. We want to have, similar to how Rust does on CPU, it gives you all the power, but like you don't need to, it doesn't like smack you in the face with it, like of the complexity, right?
Got you. Yeah. So for like maybe, I don't know, all statistics are made up, but like 80% of what an engineer might need to do, they could use like this higher layer stuff that gives them all of Rust benefits and guarantees around memory safety, thread safety, type safety, all this great stuff. But then there might be the need for some specialists that are maybe like aware of how GPUs work and might need to tune like 20% of the code to use that more like raw layer, that unsafe layer.
Absolutely. Yeah.
Gotcha.
And I think, even on most of the languages that run on the GPU do not have as robust of a type system. There's some new ones like Mojo, which they're sort of taking the ideas from Rust and bringing it to kind of like a TypeScript for Python, focused on the GPU. And but how do you model something in the type system such that it feels natural and then it's zero cost and you get those safety guarantees? And we don't really have much to look at of like, here's standard file system abstraction, which obviously we have for CPU. There's not this just like inherent, of course you have a file and you can open it and you can do these operations with it on the GPU. So we haven't sort of taken the problem space and pushed them into a like high quality type system. And that's something I'm really excited about, is like getting as much into the type system and at compile time and zero cost as possible.
Right. It seems like a sort of an entirely new frontier of computing in that sense. You're like, okay, we have raw horsepower, like how do we harness it a bit in a way that we can help out those 80% of engineers that need to use it, but may not be in the minutia and the details of how GPUs work. And for that, that's wild. That's really cool.
And the abstraction's important because then when you get to reusable code, right? Like again, on GPU, not a lot of code is reused. It's not like, oh, somebody already wrote this, I'll just pull it off crates.io. Like it's a lot of copy and pasting, it's a lot of re-implementation. And, obviously we've seen the light, we know better, like, why write the same thing multiple times that does the same thing?
Yep.
And so there'll be like, getting those abstractions right means you'll be able to not only interface with other GPU code, but hopefully do smart things and interface with CPU code as well. And so I think that's going to be a really important part of both language design and research and just people trying stuff, quite frankly. Feel what feels good. We're sort of at a unique opportunity where there aren't really people writing Rust GPU code, so it's not like it's almost like early Rust where we're not boxing ourselves in because we're breaking people all over the place, or there's a bunch of existing crates that are written for GPUs. Sure. And so we have the freedom to experiment right now, which is an exciting thing.
Yeah, you're early enough. And then I guess you would, as things mature, understand like what is a one-way door versus a two-way door when making decisions and going like, okay, now we have succeeded. We now have customers. We now have people that are using our stuff. And how do we impact them? So yeah, it's amazing. So like you'd mentioned about, computer vision actually. So I work in automotive. In automotive, we're starting to see that like no longer are like support vector machines being used for like identifying a vehicle so that we can do like autonomous emergency braking, out of a camera image. And it's more like, okay, how do we bring in ML? How do we bring in like deep learning? Do you see that the work that you're doing being impactful for sort of those spaces like safety critical and spaces that are starting to now see an adoption of newer technologies like using Rust on a GPU.
Absolutely. I think to your point, like that, all the safety stuff and all the vision stuff is coming to, and it's generally on device, right? Like you can't do it in the cloud and just ship the results. And I think the GPU is just the way you do this stuff. And right now, even if, let's say you wrote your Rust embedded stuff, you would have to kick out to like a CUDA C or something like that in order to do this vision parts. And so I think this can help enable that if you do want to stay Rust specific, or even if your code base is C++ or whatever in embedded, and you're like, well, I would rather write Rust for the GPU parts. You can output stuff, and it can be, you don't get the benefits if you have a Rust host and GPU code running Rust, but like you get at least some benefits, at least the developer experience benefits, and I think that's going to be a place where, as the Rust, you can speak to this better than me, the like validated compilers and stuff like that. I think there's demand for that, and I think the GPU stuff will come hand in hand because there's demand in the market for that.
Yeah, I'm definitely excited to be writing some maybe like rust-cuda or Rust GPU code in the future, like targeting automotive controllers, like at higher levels of safety criticality. Like this would be really awesome to see. To your point on the safety critical side, we still have some steps to take. I think you have some steps to take, and like on this journey, we'll meet somewhere, and then it'll be like, yes, let's do it. So, and I think we're kind of reaching like a little bit of a wind down phase here. So I wanted to really ask you if you have anything you'd like to share, anything you'd like to shout out, anything like that as we kind of wrap up.
Yeah, I think the Rust community has done a great job, and we want to be a part of it, and I really enjoy it. It's what I do for fun, and now for work. So thank you for having me. And we're hiring Rust engineers, so look me up. And yeah, we really want to be good members of the community because we are members of the community. So as we kind of push this stuff forward, we want it to be a community effort and not just sort of us in the background doing things. So please come join, please contribute, even if it's just trying it and saying it sucks and it's hard. And that's good feedback. Good feedback.
Open a discussion and say that it sucks.
Yeah, right.
Let's follow the process properly. So,
But yeah, so thank you for having me, and this is great.
Cool, yeah. So really appreciate you coming out, Christian. Again, this is Pete from the Rust Content team signing off. So take care, everybody. Bye.